My name is Bud Werner, more specifically Orville Werner. I first became involved in concrete, in producing concrete aggregates when I was going to college. And I got out there and I used the loader and I did all sorts of things and tested concrete aggregates. Once I got out of college, I started working for the Bureau of Reclamation. And as such, I was an inspector on a concrete-related project here in Colorado. After 2 years, I came to the concrete research division of the Bureau of Reclamation in Lakewood, Colorado. And from that point on, for 13 years, I was involved in mass concrete jobs, which the Bureau of Reclamation typically did. I currently am president of CTL Thompson Materials Engineers, and as such, I'm primarily a consultant, a senior consultant to the concrete industry on all sorts of matters related to concrete. I first heard about natural pozzolans probably to any detail after I started working for the Bureau of Reclamation. I started working for the Bureau of Reclamation right toward the end of their massive push to develop water resources in the western United States. And this massive push consisted of building structures to save and distribute water, primarily for agricultural use. These projects were begun after the Bureau of Reclamation came into being, which was shortly after the turn of the 20th century in the early 1900s. And these dams were made with cement, Portland cement, which had been invented some time ago. But they were such massive structures that they really had a problem with heat being involved. And as such, they were always looking for ways of keeping that heat down because it caused cracking. Early on, they determined that they could use something called natural pozzolans, which were earthen materials taken out of the earth and processed in such a way that they contributed to this strength gain without putting so much heat into the system. And as such, I looked at some of these structures. I did research on them to see how they were developing in strength, including, for instance, Yellowtail Dam. And Glen Canyon Dam is one that comes to mind that had natural pozzolans in it. Yes, it was a much different environment then. The main difference, we can start with cements. Cements were much different than they are today. Portland cement tended to be slower in gaining strength. It had not been developed to the point that it is now, that we get the instant gratification of early strengths. And as such, we didn't expect high early strengths necessarily, which made it easier to transition into pozzolans at that particular time. The aggregates themselves, we had unlimited amounts of aggregates, so to speak, in that period of time. The Bureau of Reclamation at the time I was there had a person that all he did was keep track of the aggregates that were in the vicinity of a project that was going to be built. Bob Hess would religiously put all of this information in there, and I would just have to go to that book and look at what was available and specify concrete accordingly. And I typically didn't have to worry about alkali silica reactivity, for instance. At that particular time, I could choose an aggregate that didn't have that problem. And I also knew that most of the cements were low alkali cements, and we specified that. So that's the aggregates, that's the cements. The admixtures were very simple in those days. Water-reducing admixtures weren't discovered until, I believe, the early 40s, late 30s. And air-entraining admixture, the benefits of that wasn't really discovered until 5 or 10 years after that. And when I started in the business, there were just a few available admixtures for those purposes. Superplasticizers weren't invented. So we just had limited choices when we were making concrete at that point. Nonetheless, we could choose from the best of what was available. To me, I believe the most impressive use of that was in mass concrete, in dams. And again, I mentioned earlier that there was Glen Canyon Dam, which was built with a natural pozzolan that was discovered and processed very close to the construction site itself in Arizona. This dam, if you go there today, is just a massive structure, beautiful to my eyes as an engineer, of course. But it worked well. It worked in spite of the fact that they didn't have decades of experience with natural pozzolans being very successful. The Bureau of Reclamation at that point had a very active research and project support system. And they studied these mixes very closely and just found the right combination, somewhat by chance, somewhat by hard work, and it worked very well. In my experience, in my early years with the Bureau of Reclamation, I actually specified and used natural pozzolans in several projects. In California specifically, when we were building Auburn Dam in California, we used a natural pozzolan in there. We called it lacenite at the time. And there was another pozzolan named Arex, which was available for other projects that we might have in Southern California. So these were used fairly guardedly, not a lot, but they were used when they were locally available to be used by the Bureau of Reclamation. That is about the time, though, that the Bureau of Reclamation and others started doing a lot of research on fly ash itself. And fly ash being a material which was already there, didn't need to be processed, and really had some desirable properties above and beyond what natural pozzolan had, became economically a better alternative. And this pretty much shoved natural pozzolan to the back at that time. Yes, there were. There were no catastrophic failures that I'm aware of, let me put it that way. But there were a lot of lessons to be learned because they were trying to apply this technology fairly quickly to Portland cement, you know, ancient history, which we hear from others who have really studied that. Pozzolans have been used in conjunction with lime, and quite successfully. When they started using it with Portland cement, it was a little bit different, I believe. For example, Lahontan Dam in, I believe, Nevada or California was built in approximately 1917, and they used a ground-up quartz material as opposed to a glassy silica. And in this particular case, it was not used very successfully. It didn't really give them the strength, and it turned out to be not very durable and freeze-thaw, although admittedly that was before air entrainment was known. Then they started finding different materials which might work better, which might be more reactive with Portland cement. And of course, some of these were the diatomaceous earths, such as lacenite had. And then they figured out how they could calcine materials to make them better also. In today's political and environmental climate, we are running out of readily available good fly ash to perhaps sustain us for a long period of time in what we're doing. I mean, we're not out of it yet. It will be around for a long time. But it is going to become more and more valuable to us, and such economic pressures will make it more valuable in terms of how much it costs. The reason, as I stated previously, that natural pozzolans became out of favor probably was because there was a cheaper alternative, an easier alternative. It's not going to be cheaper and easier forever. There's no doubt about that. Natural pozzolan is a very, pardon the pun, natural way to go because, very simply, it has been proven in the past. There are other supplementary cementitious materials which have not been proven yet, which someday we will, as an industry, look into and figure out how to use. But natural pozzolan has a very short learning curve at this point. There is some learning to be done because you look at someone such as myself who has over 40 years of experience, who at the beginning of his career saw a little bit of natural pozzolan used and then saw it mostly disappear. There aren't a whole lot of people that have used a lot of it now, but it's there. The biggest resistance is going to come from the lack of standards which will enable its use. And we need to work on that as an industry as well. Right now there are standards for natural pozzolan. There is a lot of discussion that they aren't really applicable, that they're much better suited for fly ash, for instance. But we need to get the standards which will make structural engineers and owners comfortable with this change. And it goes right down to the major standards that we use for construction, which, for instance, 301 on concrete used for construction. The people that look at that don't have the in-depth knowledge that a few of us have, and they need to be reassured that this will work. When you compare natural pozzolans to fly ash, there are some striking differences, obviously, even though they all are specified under ASTM C618. For instance, fly ash itself is a very round particle, very easily makes concrete more workable. We're used to that. Natural pozzolans are ground up much like cement is, and so they're a little bit harsher particle, and they may require a little bit more water or water-reducing admixture or a difference in proportioning to make them as desirable from the standpoint of durability and water-cement ratio and that sort of thing. Fly ash, on one hand, has a tendency to have carbon in it, and this carbon is very disruptive to building concrete structures in freeze-thaw environments because we want to put air in it. Natural pozzolans don't have this particular problem. So they are certainly different materials, and as such need to be treated, I believe, independently in assessing how good they might be for any particular project. I think what we have to do, which is difficult to do because we have a century of specifying things prescriptively, is we need to look at performance specifications and put them on the same level in terms of performance, but not in what they are. And finishing of concrete is one area where natural pozzolans are going to have a learning curve, just like fly ash does. Most finishers just hate to admit that they can take concrete that has anything but just plain old cement in it. But the point I would make is finishers today, as compared to finishers 40 years ago, a finishing crew has to do 3 or 4 driveways a day to make money just to exist. In previous years, the finishers were paid well enough and their economic demands were low enough that they could do 1 or 2 a day. And it makes all the difference in the world in the terms of the quality of the job that you get, because it takes time to place concrete properly.